engineer at Microsoft with 15 years of experience in building version control tools at Microsoft, GitHub, and SourceGear. He will reveal more secrets about the Git dilemmas and their solution. Enjoy and applaud Mr. Edward Thomson.
Again, my name is Edward Thomson. Real quick introduction. I'm a program manager at Microsoft. I work on the Visual Studio Team Services team. For those of you who don't know what Team Services is, it's Microsoft's website that allows developer collaboration. So it's version control, bug tracking, continuous integration, continuous deployment. It's all the tools that you need to build Agile products within your company. And we build Visual Studio Team Services to be something that we sell to end users and provide to end users, like your companies, so that you can build Agile software development methodologies. And what we didn't know when we built it was that we were going to want to use Visual Studio Team Services in our own organization. So one of the things that we've been doing recently within Microsoft is we've been moving to what we call one engineering system. The goal is to move every project and every developer within Microsoft into Git and host it in Visual Studio Team Services. The motivation for this was really simple. If you look back to 2010, Microsoft was simply not Agile. We weren't doing Agile methodologies, and we weren't delivering value quickly or continuously. And this was a problem for us. And so I write dev tools, I write version control. So I tend to look at Agile problems from a version control mindset. And so I look at an organization and I see the way it organizes its source code. So if you looked at the common way most teams within Microsoft organize their source code 7 years ago, 10 years ago, I've got a picture of the branching strategy that we use. Oh, nope, sorry, that's the wrong slide. It's close though. So if you look at the way that the Windows team, for example, has historically organized its branching. You have one main branch called the Windows Release Branch. And then we tend to do something we kind of call shipping the organizational chart. So we don't have feature branches in most of our projects within Microsoft. We have branches that align more or less with the corporate structure. So within a Windows branch, you have Windows 10 as a branch, you have Windows Server, you have Xbox. Xbox, of course, is built on Windows, and so they're in the same repository. And this doesn't look so bad at first, except that this is just the first level. This is almost a fractal sort of a problem. When you start zooming in, if you look just at Xbox, then they've got branches amongst themselves. This isn't actually a real hierarchy. They don't like me to talk about what it actually looks like, but it's just an example. And the problem with this is that in the Windows branching structure, what happens is developers end up working way up here in their top branch. And then their code, when they check it in, eventually gets integrated to the next higher up branch. So, into the divisional branch. And then from there, the next higher level. So what happens is when a developer checks in some code, it can take a week or 2 weeks before it hits the rest of their division. And we're just talking about people, say, making the startup screen. And from there, that team will then integrate the next level. And then the next level. So it can take weeks. If you're an Xbox developer, it can take weeks before everybody working on the Xbox platform actually gets the code that you checked in. And that's just Xbox. Then you've got to integrate into the rest of Windows. So this is a huge cycle time. If it takes several weeks just for the rest of the developers on your team to get your changes, it's going to take months
or maybe years before end users see it. That is not Agile, right? So one of the things that we want to do at Microsoft is break down the amount of time it takes for our developers to get their code into the hands of the users, like you. And the way that we have really enabled that is with new version control tools like Git. Can you put up the question on the screen, please? So I'd like to know how many people are using Git for their software development today. Okay. Are you using Git? Yes. Are you using Git? No, and I don't have any plans to. Or are you not using it, but you intend to in the future? Wonderful. Obviously, an overwhelming response. Most people are using Git. Thank you. If we could go back to my slides, please. So Git is undeniably the standard version control system for all software development, but especially for teams that want to do Agile development. The branching structures that Git enables is simply, unbeatable when it comes to an Agile methodology. You can use something like Git flow, and you check out a simple topic branch, you keep it short-lived, and you get your changes into the master branch as quickly as possible. That lets you deliver your changes to your customers quickly. Okay? And 10 years ago, we were absolutely using nothing like this at Microsoft. That is starting to turn. My team, the Visual Studio Team Services team, is using a very similar branching structure to this. And so the question is, how did we get there at Microsoft? Because Git has some problems. It has some dilemmas when you're scaling to large teams. Our goal at Microsoft is to bring large teams and large repositories into Git so that they can stay agile. What do I mean when I say a large repository? Well, I went to the Git webpage and it told me this, so everything's done, right? It told me that Git was built to work on the Linux kernel, meaning it's had to handle large repositories from day one. And the Linux kernel is really pretty big, right? If you look at it compared to some other open source projects, the Linux kernel is about 640 megabytes of, when it's checked out, just of the source code, tests, documentation, build tools, stuff like that. That's way bigger than Roslyn, which is the open source C# compiler, way, way bigger than the Git project itself, which is only 34 megs. But when we look at the Linux kernel compared to some enterprise projects, even within just Microsoft, if we look at it compared to my repository, again, the Visual Studio Team Services repository, we're actually a lot bigger. We've got 3 gigs of source and test and all that stuff checked into one repository. 110,000 files. And that sounds pretty big, but at Microsoft, we think of one repository when we talk about a big repository, and that's the Windows repository. It dwarfs everything anybody has ever seen. 270 gigabytes of source code, tests, build tools, going back 15 years. It's currently worked on by 4,000 developers at a time. In one day, there are 4,000 people checking into the Windows repository. It is enormous. And that's why they've come up with these complicated branching strategies, where when you're working on one feature, it could take weeks to get into the main line. So my team at Microsoft was tasked with getting these sorts of repositories like ours, like the Visual Studio Team Services repository, and ultimately Windows into Git. And along the way, we faced several problems. First of all, large teams. At some point, Git becomes problematic when it's scaling up to very large teams, when you have many developers working in one repository. Git has problems handling large files. So if you, especially binary files. So if you're putting images or videos into Git, if you're a scientist and you've got large data sets, game developers especially will see a lot of problems scaling Git up. And finally, just large repositories. Things like the Windows repository that has 3.5 million files over tens or hundreds of gigabytes is very problematic in Git. Let's take a look first at large teams. And what do I mean when I say a large team? We see the scale problem starting to happen at like the 200 to 300 developer limit within Microsoft, but that's kind of how we work. So this could be 50 developers even if you work in a type of system where you commit early, commit often, and push often to the server. You'll start to see these problems even at like 50 to 100 developers. And the first problem you see is that there are just too many pushes happening at once. There are too many people trying to get their code up onto the server into the master branch. You might have seen this. If you haven't, I'll just real quick demonstrate what happens when you're in Git and there's some contention getting into the master branch. I've got a project here, and I'm using the Git flow sort of methodology. And I've got a topic branch that I've created and checked out, and I want to get it onto the server. So I'm on my topic branch. I'm going to check out develop, and I'm going to merge my changes into the develop branch. That's the main integration branch on my project. And I'm going to push these changes to the server. Okay? And so what happens is, on a project that doesn't have a lot of people working on it, the server will just take these changes. But that's not true for this project. I've got a lot of people working in this project, and somebody has beat me to it. So somebody has pushed to the server before I did. And so that doesn't work in a Git model. What I have to do now is I have to actually integrate their changes, right? In a centralized version control system, if I were to just click check-in, what happens is I send my changes to the server figures out how to merge my changes with whatever's on the server. In a distributed version control system like Git, the end user, all of us, are actually responsible for getting the changes from the server, integrating them locally, and then pushing them back up. I'm not going to dig too deep into how Git works as far as its structure, but it's based on a graph, and we can actually take a look at what this means when we're doing this push. So right now, I've got a change on the server. I'm going to clone that change locally. I'm going to check it out and commit a new change on top of that. And what happened just now when the server rejected me was that somebody else had pushed up to the server. So the server is the dark blue on top. And so somebody else has gotten that change onto the server before I could get mine there. So what I need to do is I need to pull that change down to my local repository and either merge or rebase it. So I need to bring my changes, incorporate them with theirs, and now I can push again. And the server will accept my changes because I've gotten everything that was on the server as well as mine. Perfect. The problem is when you're dealing with 200 to 300 developers, or again, a very busy 50 developers, when you're getting close to a deadline, when you're in a crunch time, somebody else could beat you again. If somebody else has got a faster network connection and types faster, they can fetch those changes before you do and push them up to the server. So now I've got to grab their changes and rebase or merge. But again, when it's crunch time, this can just keep happening. And this isn't theoretical. Like my team, the VSTS team, absolutely hit scale problems just pushing our changes up to the server. Thankfully, there's an easy solution for this that you're probably already using, and that's pull requests. You're probably using pull requests for code review. They do an excellent job with scaling people getting their changes into the repository as well. That's because the merges happen on the server. There's no need for the developer to download the changes, do the merge, and then push them back up, because that favors whoever's got the fastest network connection and who can type those commands the fastest. So it reduces the cycle time greatly. So the nice thing about most version control providers, GitHub, GitLab, Visual Studio Team Services, is that you can enforce this. So you can turn off the ability for people to push directly into master and force people to go through a pull request. usually it's called protect this branch or branch protection, and it forces people to go through pull requests. So this is nice. This is a big help for a moderately busy repository that only has 300 developers in it. But if you're hitting the Windows scale and you have 4,000 developers in the same repository, you need something a little more advanced. So at Microsoft, for the Windows team, and really for everybody, we do what we call merge queues. The problem with a traditional pull request experience is if you've got 50 people clicking complete pull request, trying to get into the same branch all at once, what happens is that one of those people wins. So everybody clicks it at once, one of them gets in, everybody else doesn't. And so now when they click refresh, they'll retarget their pull requests on the newest commit, the person that did win that race. So from a user experience point of view, you're going to click merge pull request, and all of a sudden it turns gray on you. There's no way to get around that. So you've got to refresh the page. It's not an unbearable problem, but when you've got developers who are sitting idle, you're not getting value to your customers. So what we do in Visual Studio Team Services is we have a merge queue. When 50 people click complete pull request all at once, we basically line them up. We take all of the pull requests that are waiting to go into a single branch, and we just merge them one by one by one. It's very straightforward. It's very simple, and it allows us to scale to deal with 4,000 developers in the same repository. This will reduce contention, but if there are conflicts, of course, that commit will get skipped. They'll have to pull the changes down locally, resolve the conflicts, and then they can do the push. But again, just pushing to their pull request branch. They're not pushing directly into master. Another problem we see with a lot of developers is that we have too many branches. It's one of the great things about Git is that you can create branches easily and quickly, and that lets you do wonderful experimentation. The problem is that Git itself starts to slow down when you have too many branches. Git works well at the 10 or 100 branch level, but when you hit 1,000, you start to see it slow down. And when you hit 10,000, it really slows down, and it becomes completely unusable around 100,000. Who would have 100,000 branches? That sounds crazy. A team with 4,000 developers. That's only 25 topic branches per developer. If you're not practicing great hygiene, you get to 100,000 real quick. So how do you deal with this, what we call branch proliferation? One thing you can do is you can use forks. So on my repository that I use in my spare time, it's an open source project called libgit2, you can create forks, and basically this creates a new copy of an isolated repository just for you. So what you won't see is all of your coworkers' branches, you'll just see your own. And as well as the branches in the main repository. So that is a big help, but you're isolated. If you want to code review somebody's changes on your computer, if you want to download somebody's pull request and test it locally, it's actually quite complicated. You have to run some git command to set up some ref specs for the remote repository. I have to Google it every time, and I've done it thousands of times, but it's so complex it just can't stick in my memory. So in VSTS, we had to take this a little bit further. We created something we call limited branches or limited refs. So the branches that I'm interested in on this project are the master branch and the releases branches, as well as any branch I've created. Branches I'm probably not interested in are my coworkers' branches. They do great work, but I don't need it in my repository. When I run git fetch, if I'm, say, on the Windows team working on Notepad, when I run git fetch, I don't need the latest change to the Xbox UI, right? That's just going to get in my way. It's just going to slow me down. So I don't want to see that. And so with limited branches, I don't. Since I connect to the server and I'm authenticating to it, it knows who I am. And it can give me just the master branch and the releases branches that I'm interested in, as well as the branches I created. Of course, I still want to be able to download a pull request or one of my coworkers' branches sometimes in order to, again, code review it, build, test it, that sort of thing. So I can just go into the UI and I can add it to my favorites. Then the next time I run git fetch, I will actually get all of those changes. Okay. So again, forks are great, but they keep you isolated. They're great for permissions, for keeping people out of a repository. They're not great for collaborating. So limited branches helps that quite a bit. Another problem we see in Git is having large files. So Git is a wonderful system. It's a distributed version control system, which means you get a copy of the entire repository when you clone a remote. That's why it's called cloning. You get everything. So that means you get all of the commits that have gone into that repository. That lets you run git log and see all the changes. It lets you run git checkout to check out a different branch without ever having to hit the server. So that's really great. The thing is, you also get a copy of all of the blobs, all of the files that are in that repository, which is wonderful if it's source code, because it allows you to switch branches, it allows you to create new branches and experiment easily. But if you're checking in binaries, then this adds up really quickly. Binaries don't compress well, so they just bloat the repository. Okay? And you probably don't need every copy of the artwork going back several years. It's just taking up space. How do we solve that? The easiest way is to actually just get them out of the repository. So if we could get the images out, what we can do is we can replace them using a system called GitLFS, which stands for Large File Support. GitLFS will remove the large binaries and replace them with little text files that just describe where Git can go get the binaries when it needs them. Okay? So it can bring them in on demand. And it's just this tiny little file. It's 128 bytes, and it just describes where the file comes from. Okay? So we can take a look. I actually have a repository here that has some big files in it. They're actually not that big. They're just 1 megabyte pings, and I have 10 of them in my current version. The problem is, I have a lot of history of them. I've changed these 1 megabyte files about 1,000 times. So I've got a really, really large repository, and if I run git clone, it'll start to download that. There we go. So now I'm receiving objects. I'm downloading all of the history, all of those blobs, all 1,000 1 megabyte pings. And as you can see, it's not going very quickly. And I only have so many minutes with you today, so I'm going to go ahead and Control-C this and abort it. And what I'm going to do is instead clone a repository, the same files, the same history, 1,000 versions of a 1 megabyte ping, but I've created this repository with GitLFS. Okay, there we go. And now what's going to happen is it's going to download the LFS version of this repository, and you can see receiving objects went so quickly. I still downloaded 2,000 objects from the server, but instead of being those 1 meg pings, they're just those tiny, tiny little text files that describe where to find the images. And so now this is LFS taking over, and it's downloading just the 10 images that go in the current commit. Right? So I'll be able to see all the images. I just won't have all of the history. Okay? So if you're familiar with Git, you may have heard of a shallow clone, which is the ability to just get the most recent commit and the files that it references. And so this is conceptually kind of similar. A shallow clone lets you make sure that you don't have all of that history. You're not downloading all 1,000 1 megabyte pings. But the problem is, a shallow clone is actually really hard to work with because you don't have all of the data in the repository. So if I take a look at my repository, I can go in, and I'll see that I have all of the files in the most recent version, but I also have the history. So I'm able to look at all the history, all the changes, and more importantly, I'm able to switch branches. So I can check out an old branch, a different branch, and what it's going to do is it's just going to download from the server the files that I've changed. Sorry, the files that are different between those two branches. So it's very efficient. I do have to be online to get the versions of the file the first time. But after that, I can work on a plane, I can still branch, I can merge, as long as I have them locally. So it's a very effective way to save some transfer space. Finally, and this is the hardest problem we had to face at Microsoft, was the dilemma of large repositories. And again, the Windows repository that's 270 gigabytes and 3.5 million files. One of the problems with having a large repository is having a lot of history. When you run git clone, you get all of the history. And just like git LFS, you could do a shallow clone, but there are disadvantages because you want to be able to see the other branches, you want to be able to see all of the history so you can compare and go back. But even if you did a shallow clone in the Windows repository, since there are 4,000 developers working all the time, the code base grows very quickly. So even if you do a shallow clone the first time, the next time you run git fetch, you're going to get all the Xbox artwork that's changed. You're going to get the new version of Windows Server. So shallow cloning is just not an option for us. The other problem that it doesn't solve, a shallow clone, is that we have so many files. With 3.5 million files, it's just impossible to work with a repository. Running git add is slow. Running git commit is slow. Because most of the git commands are actually linear on the number of files in the working directory. And that's best case. Like sometimes it's I won't bore you with computational complexity theory or anything, but sometimes it's big O n log n or worse. And so 3.5 million files is just unusably slow for the Windows code in Git. That was probably the biggest reason that we didn't think about moving Windows to Git until very recently. And when we did, we just naively threw the entire Windows repository into Git. It took 12 hours to clone, except actually it didn't. It took 12 hours to fail to clone because there was a network hiccup the first time. Because of course there was. It was 12 hours trying to spew this much data down the pipe. But when we finally did get the repository locally, we ran git checkout, and it took 3 hours. It took 8 minutes to run git status. And that's 8 minutes spent telling us that nothing had changed. And when we did want to make a change, it took 30 minutes. 15 minutes to run git add, another 15 to run git commit. So this was obviously not going to work. Our goal was to reduce the time it took changes to get into the master branch. This obviously does the exact opposite. So we introduced a system, and in fact, rather similar to Git LFS. We introduced a system called GVFS, the Git Virtual File System. And after introducing that, we got clone times down to 90 seconds. Checkout went from 3 hours to 30 seconds. This is still not ideal, right? We want this to be as fast as possible. But at least this is a starting point where we can work with. And in fact, we have been working with it. We've been putting the Windows developers into Git over the last several months. Yesterday we announced that we put 90% of the Windows developers, so 90% of the 4,000 people working on Windows are going into a Git repository now. So they run git status, it takes 8 seconds. Again, not ideal. That's not as fast as we want it to be, but we've proved now that we can get very large enterprises into Git so that they can remain agile. How does it work? The Git virtual file system, again, like Git LFS, when you clone, you don't download everything. That's the main thing. Instead, you only download the most recent commit the most recent set of trees, so you know the repository's hierarchy. But you don't get any of the blobs. Those stay on the server, and we'll page them in as we need them. And we set up what's called a sparse checkout in Git. Because again, Git is like linear speed on the number of files in the repository. If you set this up, Git doesn't think it has those files. And in fact, it doesn't, right? They're still on the server. And then the key to all this is a special NTFS filter driver. And if you don't know the NTFS kernel internals, and I certainly don't, what a filter driver does is it basically sits maybe at a layer above the file system. So when an application talks to the file system, normally it goes straight there. If you add in a filter driver, it can intercept all of the system calls, like trying to open a file. And the NT team, the Windows team, built this for virus scanners. So when an application tries to open a file, a virus scanner can have a filter driver in the middle, intercepting the open calls, look at the file on disk, make sure that there's no virus, and if there's not, hand it back to the application. So we did something a little bit differently. We introduced the GVFS filter driver. So what it does is, so when you did the clone, you got just the repository structure at the most recent version, and none of the objects. So what the GVFS filter driver does is it reads that repository structure and projects it. So if you run dir, you'll see the files. It appears that they exist. But when you go to open one, that's where the filter driver takes over. So the filter driver says, is this file actually on disk? And if the answer is no, then it'll download it basically from Azure. And then it'll actually put it on disk so that the next time you access it, it'll be just as fast as normal. And so it'll page these files in on demand, which sounds crazy slow, but it turns out that most people building Windows touch just such a small subset of it that this is actually very efficient, as long as we, put the servers relatively near to them. Okay? So this allows us to get those sorts of speed ups where running git status goes from 8 minutes to 8 seconds. The really nice thing about the Git virtual file system is it lets us just use stock Git. It's the Git that everybody knows how to use, the Git that you're using in your projects. It just lets us scale it up to something that's 3.5 million files. Okay, everybody knows how to use it, mostly. I mean, Git's not exactly the easiest thing in the world to use, but for the most part, everybody knows how to use it. And when they don't, you can look on Stack Overflow. The other nice thing is that now every developer is in a single repository. One of the things that we thought about when we were looking at moving the Windows team into Git was splitting them up into separate repositories. That's what Android does, for example. It has many, many repositories. It sews them together with a project called repo. This is a reasonable way to scale. The problem is, if you're one of the people that works at the very low level of the application, you're making changes that affect lots of other people. If you're in multiple repositories, that means you're making changes in not just the repository that your code is in, but also all the repositories that affects. And that sort of branching, that fanning out of problem space means that you're trying to coordinate changes across so many different repositories. It's very, very inefficient if you're the person at the bottom. The VSTS team actually tried that. We spent, 2 months in that, and we basically gave up because the people at the bottom of the stack, the people who were making the big changes that affected everybody, had to figure out how to align things without breaking everything. It was very, very challenging. So having everybody in a single repository allows us to make these sort of cross-cutting changes across the entire code base. It also allows us to use all of the Git ecosystem tools that exist. We didn't invent a new version control system. Microsoft's done enough of that. We just use Git, so now Visual Studio can talk straight to the Windows code base since it's in Git. Same with SourceTree and Tower, and Git Kraken is working on support So we're really happy about that. Of course, it's not perfect. There are some limitations to GVFS as well. You've got to be online the first time you open a file, sort of like with Git LFS. More and more, we're online all the time, so this is less and less of a problem. But even on my last international flight, now I have internet the whole time. I'm not sure how many Windows kernel developers want to hack on an airplane, but it is a limitation for them if they do. Another problem is that currently we're only working on Git itself. We're making changes to the Git client to enable GVFS to work, and we're only doing that within Git. We haven't done that with JGit, libgit2, Dulwich, any of the other Git clients that talk to Git repositories. Okay. Another limitation is that there are no clean and smudge filters. How many people have used core.autocrlf and had struggles with their Git attributes file trying to figure out what they should set that to and why files look dirty all the time? That's a clean and a smudge filter. That's when you check into the repository one set of line endings, and when you download it, you get another. When you check it out, you get another. Windows users see this sort of pain all the time. We actually just turned it off. So there's no more clean and smudge filters in GVFS. It turns out that not only are our lives easier now, that was the method to make GVFS work, because we're doing that projection of the repository. We're telling you that this file exists, and we're telling you that it's this size. And we've got that data from the server. So if we were to change the data after we got it from the server and before we put it on the disk, that wouldn't make any sense anymore. We would be lying to the file system about how big that file is. And finally, some commands just don't work. If you run git grep is an awesome command to inspect your code base to find out where something is. It'll look through all the files for a particular string. The problem is that it'll look through all the files, and so it'll try to download all of the files from the server, all 3.5 million of them, and that'll take 12 hours. Finally, operations that validate object presence. So you can't run a GC, you can't run a gitfsck. Not a big deal. The Git virtual file system is getting ready for your use. If you have large projects, you work with large enterprise vendors, this is especially true with people working in like oil and gas or banking, have very large projects. We want to make this available to them. It is not quite there yet. It's currently in research and development. We are using it, like I said, within Microsoft. We've got about 90% of the Windows team using it today. But at the moment, it's not something that I would recommend for your use. It is open source. If you want to go check it out, you can. But right now, it only works on Windows. It only works with Visual Studio Team Services. We are building file system drivers for Mac, for Linux, and we hope to work with partners to extend their support so that you can use it on somebody like GitLab, GitHub, Bitbucket. Okay. If you want more information about any of these things, pull requests, of course, are at visualstudio.com/learn-git. GitHub has amazing help with how to use pull requests and how to turn on your how to set up limitations on your branch so that people have to use pull requests to get their code in. Forks, GitHub has great information, and like I said, forks are great for permissions and for rather small teams. When you get to very, very large teams, you probably want something like limited branches. We'll have more information coming out about that in the future. GitLFS support is at github.com/gitlfs. And GVFS is at aka.ms/GVFS. So that's the technical side of scaling Git up to a large organization and the technical problems that we faced. There's sort of a problem that we haven't talked about too much. And that is that Git's kind of hard to use. And I love Git. This isn't really a knock on Git, right? I work on Git every day. I've made changes to Git. I maintain open source projects with Git. But to be honest with you, it is sort of hard to use. It's got some strange commands, like rebase especially, and the fact that checkout does about 3 different things. It switches branches, it creates new branches, and it reverts file changes. I'm sorry, it undoes file changes. Revert is a completely different command, adding to that sort of confusion about Git. And when you get these commands wrong, it gives you strange error messages. And especially with around line endings, it gives you strange error messages. And when you want to understand what these things mean, it gives you strange documentation, like forward port local commits to the updated upstream head. It took me a long time to realize that that meant rebase, or join 2 or more development histories together. That's merge. It seems like these things could have been specified a little bit simpler. I've got to tell you, there's a little bit of a lie in here. One of these isn't even a real documentation from Git. Git's documentation is so notoriously bad that somebody has created a fake documentation website, has fed all of the documentation into some machine learning and spit out the results. And it comes up and it's completely unreadable, but it's no less readable than the Git documentation was in the first place. That's how bad the Git docs are. So that was a problem that we had to solve as well. It's a problem that every team using Git has to solve, of course, but when you're trying to onboard several thousand developers into Git, it became a problem at scale. So our solution, of course, was just training and education. As far as education went, we gave out wikis, we did tutorials, and we did in-person training. But that's really, again, tough to scale. It's hard to get 4,000 people in the same room and to learn at the same pace, learn in the same way. So the most effective thing that we did was to build out champions within each team. So we would split up into smaller teams. So for example, kind of the way our branching structure used to look. We would have champions at each level. So within a 6 to 10 person team, there would be a Git champion. Beyond that, there would be a meta champion, if you will. And the goal is that we can train experts in each team about Git so that they know what to do, when something goes wrong with a rebase. They know how to undo changes that you didn't want to make. They know what happens when you've lost all your files. And so we can train experts at each level instead of trying to make every person in the company a Git expert, because again, that just doesn't scale. So we can embed them at each level so they can work just within their teams. It's much more effective. Of course, we also have a mailing list, and we expect some sort of quick response, because anytime 4,000 developers can't get something done, if you've broken a build, or if you can't push to master, then the company slows to a halt. So we have a mailing list for important issues that need immediate response. And of course, we tell people to use Stack Overflow, and we also have an internal Stack Overflow. You can get Stack Overflow Enterprise and install it within your firewall. And we've done that for helping people get answers to questions. So again, there are a lot of problems scaling Git up into the enterprise. If you're facing these sorts of problems, I hope that you will look at pull requests. I hope that you will look at Git LFS, and I hope that you will look at GVFS. And with that, I'm going to leave you to go to lunch. Thank you so much for your time.